Notes 3-4, the chain rule. So as may be becoming clear, when I introduce a new technique like the product rule or whatever, I try and do it using a problem that can be done the old way and show that the answers are consistent. And then maybe we start to see things that couldn't have been done at all previously. So the chain rule here, the first problem, yes, you could just FOIL it out. Product rule requires writing this as a product. So multiply it by itself in order to square. So the product rule says the derivative of the first thing times the second thing plus the original first thing times the derivative of the second thing. Fine. Okay, and then the chain rule. The chain rule says you look at the outside first. So the derivative of thing squared is 2 thing to the 1, and then we deal with the derivative of the inside afterwards. So I always draw a little arrow to remind myself to take the derivative of the inside after and not stick it in. So 2 times the original inside to the first power, and then the chain rule says multiply by the derivative of the inside. Okay, so there's 2 ways to show that they have the same answer. One is to FOIL the heck out of everything, but there's an easier way. If you look at part A, look at part A. We've got function times 3x squared plus 6x, and then function times 3x squared plus 6x again. So part A is the same as 2 of the thing. Okay. And that is the same as what we got in part B. All right, so now let's take a look at things that are painful. We don't have a good way to do this one except using limits unless we actually use the chain rule. So this is thingy to the 1/2. So 1/2 thingy to the negative 1/2 chain rule. The biggest mistake people make is they try and put the 2x plus 3 inside instead of afterwards. So I try and encourage drawing a little arrow. The original inside goes inside, and the derivative goes afterwards. I'll just write a little note. Okay, this one we could have done the old-fashioned way, but notice if I do choose to think of this as a 3, I can, as long as I'm thinking of it as a 3x cubed to the negative 1. Then the derivative is going to be negative 1 Foohickey to the -2. Don't be afraid of blank parentheses. And then the chain rule. So also a little note. Okay, so normally we need to put parentheses around the derivative of the inside. This one you don't because it's just one term. Okay, next. Don't forget this is Foohickey to the 7/3, not 3/7. So 7/3 Foohickey to the 7/3 minus 3/3 is 4/3. Put the derivative of the inside. Remember, I've already taken care of the 7, so the inside is 2t cubed plus 5t. And the chain rule says times 6t squared plus 5. All right, this is thingy to the -1. I use blank parentheses. Don't be afraid of them. The inside is 3x plus 2. If people just try to write from left to right, they often forget the new exponent. Speaking of which, don't forget the chain rule. The chain rule and the product rule come back to bite you over and over again in the next few weeks because they're not optional, and if you have a product, you have to do the product rule, even though it's not the section on it. If you have a chain, if you have an outside and an inside, you have to use the chain rule. Okay. Okay, so the derivative of 2 to the x or 3 to the x or whatever. So notice that a is the same as e to the ln of a. E to the and ln, so e to the, let's call it e to the x, and ln x are inverses. They'll cancel each other out as long as they are right next to each other. So a to the x is e to the ln a times x, which is the same as e to the ln a times x. Fine. The derivative of a to the x is going to be the derivative of e to the thing. So the derivative is, what's the derivative of e to the x? Let's just recall. It does not follow that pop the exponent down rule. That only works for constant exponents. So the derivative of e to the thing is e to the thing, chain rule. And the inside is ln a times x. That's terrible. Here, let me rewrite that. Eraser time. And the chain rule is on the inside. What is the derivative? Derivative of 7x turns into just 7. The derivative of ln a times x turns into just ln a. So the chain rule pops out an extra ln a. And remember that e to the ln a times x was just a fancy word of writing a to the x. Okay, so let's just practice that. The derivative of 2 to the x then is 2 to the x times the ln of the base. I don't know if you remember when we practiced looking at things that might be their own derivatives and we checked out 2 to the x, we got that the slope at 0 was 0.693 something. ln2 is 0.693 something. Okay. Look at this. This is a product. So the product rule is in charge. Let's put this back in red. And we won't be doing the new rule until we get to g prime. So f prime is 2x times the original g, and then plus the original f, and the derivative, again, if the base isn't e, you just multiply by the ln of the base at the end. Okay, next. This one's going to have two chain rule things. The derivative of 5 to the thing is 5 to the thing times ln 5. But then we have to deal with the fact that thing isn't just x. So we have a chain rule that says you have to multiply by 2x plus 3. Don't forget parentheses around the 2x plus 3. Come back here. Okay. Oh, look, another product. Product rule, bless its little heart. Okay, derivative of 3 to the x is 3 to the x times ln 3. And then the original g. And then the original f is just 3 to the x. And the derivative of x cubed is 3x squared. There you go.